Good afternoon again, everyone. Welcome to the last plenary talk for the 26th SINSM for the Department of Mathematics and Computer Science. Um, our speaker, Professor Rizavel Addawe, graduated BS Math at the St. Mary's University in Nueva Vizcaya and pursued her MS Statistics and PhD in Statistics in UP Diliman. She is currently our department chair for the Department of Mathematics and Computer Science. And her interest includes statistical modeling and statistical analysis, data analysis and statistical analysis. Let us welcome her as she gives her talk in Introduction to Statistical Modeling in okay. Ma'am Vel.
Yes, Cindy. Good afternoon. Thank you for the brief introduction. Magko-closing na ba ako?
Hindi pa po, ma'am.
Okay, sige. Now, let me share my slide. Naka-share na ba?
Yes po.
Ayan, okay. Wait lang. Hindi ko makita ang sarili ko. Paano ba? There. Okay. Okay, good afternoon. The rest are still logging in. Okay, but we have to keep our time, our schedule. So it's now 2:46 p.m. And I guess I have to do this in about 1.5 hours. Okay, so I should finish my lecture in 1 hour for the Q&A. And then we'll have the closing, right, at 4:15. And that will be up to 4:30 p.m. Okay. So maybe we can just have few more minutes for those who are coming in. Yan. Tumutunog pa eh. Tumutunog pa yung ating mga computers. Okay? Let's have a review. 177 on the Zoom conferencing. We are not on YouTube, right? Nasa Zoom lang tayo. Cindy?
Meron yata, ma'am.
And this
Sir
is
Francis, can you confirm, please? Yes, ma'am. We're also in YouTube.
Okay, thank you. Okay. So we'll start. Introduction pa naman eh. So makakahabol pa yung iba. Okay? So this is my lecture. We have to do some introduction on the statistical models, and I will use R, although hindi naman pure R. By the way, what is R? Wala po akong kinalaman sa R, no? Okay. Ginagamit ko lang siya. Nagkataon lang po na Rizavel ang pangalan ko. Okay. Para lang mahintay pa yung iba, no? I'm just checking the chat. Good afternoon. Okay. Ayaw umandar nga eh. Bakit? Okay. So this will be my 1 hour lecture. An introduction. Well, hindi ko matatapos lahat, no? Masyadong mahaba po yung R package. But before I end this lecture, I will give you an overview. Okay, maybe I can share the online tutorial that we are using in the DMCS for our students, most especially for the elementary statistics course, for the mathematical statistics and for the electives. So elective in statistics who or that are taken by our graduate students, the MS Math and the PhD Mathematics students. Okay. For the introduction, let's start with the question, what is R? Okay, R is a programming language and software environment for statistical analysis. Okay, there are graphics representations and of course the reporting. There's a group involved in this development of the R. Okay, we call them the uh, R core team. Okay? So the core of R is an interpreted computer language which allows branching and looping as well as modular programming using functions. R allows integration with the procedures written in C, C++, .NET, Python, Fortran, and other languages. R is free. Okay? So, yun yung pinaka-importante. R is a free software. And you can use it using Linux, Windows, and Mac. Right? So, it's not very difficult to handle. Okay. So, ano po yung evolution ng R? R is originally written by Ross Ihaka and Robert Gentleman from Auckland, New Zealand. It started in 1993. So many individuals have been contributing to this R. Okay, they are contributing R packages. The core group of experts have been managing R source code since mid 1997, and we call them the R core team. Okay, so what are the features of R? R is well established, simple, efficient, and it includes conditionals, loops, user-defined recursive functions, and the input-output facilities. So the usual programming that you do may be in Python, in C, C++, and more. R has an efficient data handling and storage system. R's library of functions supports arrays, lists, vectors, and matrices. So you can actually do all mathematical computations like a calculator or any spreadsheet that you want to handle. The tool, the tool set provides a large and coherent collection of data analysis tools. It also contain database or databases for sample exercises or any research engagement that you want to handle. It provides graphical facilities for data analysis and displays either directly at the computer or printing at your documents or papers. Okay. So what is the claim or what are the claim of R? Well, like any other programming languages, R now is the world's most widely used, but then in is statistics, okay? And they claim that it's the number one choice of data scientists and supported by a vibrant and talented community of contributors. Well, of course, this is our talking to you now. You can also have other languages like Python, MATLAB, or any other. R is taught in universities and deployed in mission critical businesses and among their applications. Okay, so let's have some examples of these R languages or R graphs and charts. Okay. Okay, so I'm giving you just simple graphs, no? Because we cannot do everything. So ito lang yung mga examples that we do, and I can give you uh, what direct interpretation, and these are the things that we do in math or in UP Baguio. Okay, for example, if you want a pie graph, then you will use the pi function of R. Okay. So in R, the pie chart is created using the pi function, and there are parameters that you should include, like labels, colors, and the titles, the x-axis, the y-axis. Okay? So this is now the syntax, the basic syntax of doing a pie chart. First, you should have a data. Okay? I put here a data on the active cases of COVID-19 in Baguio City. 224, 301, 442, and 5. And they are located in the hospitals for the 224, 301. These are tentative facilities. And then we have home isolations. So some of these active individuals, 442, are actually on the home isolation. And 5 of them has transferred. Ibig sabihin, they went out of Baguio City. So we now want to graph these individuals in a pie chart because we want to compare the portions. So if we do that, it's a very simple graph actually. I didn't put the numbers, I didn't put the percentage. Okay, but then in R you can also put all of them. The percentage, the numbers, you can add colors, okay, you can do 3D graphs and so on. So these are now the confinement of Baguio City COVID-19 active cases. There are about 989 for this pie graph. Okay. Most of them are in home ISO. Okay. Some of them are on temporary facilities. This one are on the hospitals, and this uh, went out of the city. Okay. How about for the bar plot? Yeah, you can also do bar plot. Kailangan nga lang marunong kayong mag-input ng data. For example, your data would be 13, 12, and so on up to this. Okay. Now, these are cases naman, no? In the months of March 2020 up to May 2021. And I want to make a bar plot of this data. Now, why bar plot? Because I want to compare the heights or the increase or decrease of these cases. Okay, so I put there bar plot. Cases would be my data. Names would be the label of all of this data. And I want to label my x-axis, my y-axis, and I want a color blue. Okay, and then I put there my title. Okay, ano kayang lalabas? There. So that's the bar plot. Okay. So using this bar plot, we can now see that in this month, 1, 2, 3, 4, halos walang cases, no? And then ito nagkaroon na, and then nag-increase. Siguro nagbago tayo ng quarantine policies, and then konti ulit. And then here comes October, umakyat siya. Ba, umakyat na din. And this one is April. April ito, pinakamataas. Right? And this one is May. This is just a 1 week data. So you can see the increase, no, from March to a year. Andito na yon. After a year, no, we expect sana umunti na. Pero hindi. Actually, paakyat pa lang siya. And this is, what? So may wave tayo, paakyat, no? So sana pababa na siya. Ayan. Right? So that's the bar plot. So double-edged itong ginagawa ko, no? Nag-explain ako ng COVID, tapos nag-graph ako, and then at the same time, I'm explaining the R, the R language that we use, no, for the analysis or the graphing. Okay. Sana masundan niyo ako. Now, later on, I will teach you how to, or I will show you a tutorial of this R online. Sana hindi ako abutan ng oras. Alright, next. Okay, now how about a histogram? If you want a histogram, then you can also do that in R, right? So, what is a histogram? This represents the frequencies of values of the variable, no, into ranges. Histogram is similar to bar chart, but the difference is that it groups the values into continuous ranges. each bar in histogram represents the height of the number of values. So in R, we use the function his. Okay. This function takes a vector, ibig sabihin, you should have a data, as an input and uses some more parameters to plot, like the title would be main, the labels for your x and y, the limits of your x and y, and then the breaks. So ilang bars bang gusto mo? So you can put colors in it, you can put borders. Okay. So if I want to to get a histogram or the frequency of these ages, ages of I think this is the COVID-19 infected. So if you do that, I put there, ang label ko is age, color green. Then my border ako na red. Limit ko for X is 0 to 110 because well, maybe there are 0 ages. Siguro wala namang 110. But I just put there 110 to complete the x-axis. Okay. And then I have here y, right? Because in every age siguro, wala namang more than 10, or let's see later what will happen to the histogram. And then breaks ko, you can change this, pwedeng 10 up to 110. Okay. So what will happen to the graph? Okay. So ang breaks ko, 10. Actually, 10 ang ginawa ko. Okay. So, how do you interpret this? So, meron siyang actual or realistic interpretation because I actually use
Joseph,
the
may
actual
nag-run
data.
atin sa track natin.
Minus
Okay.
Evaluation form.
Sorry po.
Ni
Hello. Okay. May I continue? So, ito po yung ages, no? Meron tayong age 0. Yan. I think there are 6 of them. Meron po dyan mga babies who contracted the disease. Then meron tayong above 90. Ito yung 80 to 90 and so on. Pinakamarami po ito, 60 to 70. Alright? So yung mga medyo may age na dyan, katulad ko, yung mga nandito na, hindi naman siguro, wala pa ako dito. 60 pataas po, ayan ang pinakamarami. Alright? Yung 40 pataas actually. So if you are below 40, konti lang po ang nai-infect. This is, well, in particular sa Baguio City. If you're below 40, konti lang yung chance mo. Okay. So if I take this as true value of the mean or the statistics, no, ganun po yung interpretation. Right? So, anong age ba yung pinakamarami? So you can revise the graph. Siguro, ay, nasaan na siya? Sorry. I think I deleted. Alright, na-delete ko yung aking graph. And anyway, hindi, kung gusto nyong makita yung mga tig 100 o tig isa, like ilan ba yung may 0 age, 1-year-old, 2 up to 100, then you can just put the breaks here, 110. So, sana ito, medyo mali po yung nalagay kong graph. If you put here breaks equals 110, then magiging per age yon yung lalabas dito. Alright? Sorry for that. Next, let's do line charts. Okay? For example, ito naman ngayon ay these are frequencies, no? With respect to months. So meron na tayong ilang months. From March, that would be 1 year. Okay? This is January, February, March, and then April. Okay? So i-graph natin. So you can put there, this is the type. Ang type na nakikita nyo dito, ito yon. Okay? It's red. You have here the title or the label for the x-axis, the y-axis, and then there the title. So you can change this. Okay? So kung gagawin natin yon, no? Then mag-iiba siya. Now, this time I put the what? My data would be the new cases. When I say new cases, these are the daily new cases from day 0 up to day 250. Pero yung day 0 ko dito is about mga September 1 ito. Okay? Hanggang sa May 6. This one is May 6. So ibig sabihin, ito yung pinakamarami is your April, no? April po yung pinakamarami and then pababa siya ngayon. Ngayong buwan ng Mayo, sana continuous na to. Bumababa yung ating daily reported cases. Right? I think this one is on mga October. Okay? December, bumaba kasi siya eh. Yan. Tapos biglang tumaas ulit ng April. Yung black dito are the deaths. Okay? The deaths comprises about 3% of the population of, 2% of the population of the infected. Sa infected naman, right? At ang infections natin, kung bibigyan natin ng statistics, the total infections in Baguio City is about 3% of the population. 89% have recovered, 2% have died, and the rest are active. Okay. So, let's try doing scatter plot. So you can display a scatter plot by using the function plot and then with these variables. Okay. So you should have the x variable, y variable, your title, your label for x and y, and then the limits of your x and y. And then you can put some revisions on the axis. So this is an example of the scatter plot. I did this because I want to correlate the ages of the individuals who have expired. Pag sinabi kong expired, yun yung mga death cases natin. There are actually, ito kinuha ko siya. 89 lang yung data points ko dito because yun lang yung meron ako na data. Yung ages and this one. Yung friends dito are the contacts. Yung, kasi, di ba may contact tracing? So, these are the people who have died. And ang ages nila nandito, 40 pataas. These are babies. Tapos meron tayo below 10 years old na isa. And then all the rest ay mas mataas sa 40. So yun po yung mga death cases natin. Gaya ng sinabi ko kanina, mas mataas yung probability na ma-infect tayo if we are above 40. And mas mataas din yung probability na mamatay ang isang infected individual ito sa COVID-19. Okay. So ito yon. And then, gusto kong i-correlate doon sa number of contacts. Kung mas matanda ka ba, or if you're older, do you have more of contacts? Kunwari ito, more than 50 ang kanyang contacts, pero nandito siya, mga 55. Alright. Pero ito, 80 na siya, siguro mga 83, no? Pero, ito naman yung kantang number of contact. So, taking a look at this scatter plot, no? Walang correlation whether you're old, you're young with the number of contacts. Okay, yun yung sinasabi dito. Okay. So you can do that in R. You can do plot. You can get the correlation actually. Okay. So, ito naman yung mga old age with hospitalization days. Pag mas matanda ka ba, mas mahaba ang hospitalization days? Well, you can take a look. Can I superimpose a line here? So, parang hindi rin, no? So, parang walang pinipili talaga. Well, depende kasi sa comorbidities eh. So, kung may comorbidities ka, mas mahaba talaga yung hospitalization days mo. Pero taking a look, no? Comparing age with the hospitalization days, parang wala siyang correlation. Okay? Well, 89 lang yung kinuha ko dito. Okay, so you can do more analysis on that. Okay, you can do linear regression. Well, but taking a look at it, dahil mahina yung correlation, then mahina rin malamang yung linear regression. Okay, So, ano naman yung linear regression? Linear regression is just the equation. Mga mathematicians naman kayo, ito lang yon. Y is just ax plus b. A here is the constant, no? Yung coefficient ni x, or you can have that as the slope. Okay, di ba? Slope to. And b is constant. Ito yung intercept. Alright? Kung titignan natin to later, this is actually the mean of your y. And then bigla siyang tataas. Depende sa value ni A. Okay? And the syntax would be LM for a linear model. Y is your dependent variable and X is your explanatory variable. Ibig sabihin, dalawa lang yung variables ko dyan. I have the X and the Y. So I want an equation of Y in terms of X. So depende, ano ba si Y, ano si X. Right? Let's have an example. Okay, example lang to para mas madaling intindihin, no? For example, kinuha ko to doon sa mga tutorials. Okay, so hindi na to related sa COVID kasi mahirap kumuha ng correlation or function out of the variables na meron tayo, available data na meron tayo sa COVID. Okay? Kaya naman hirap na hirap natin malaman kung ano yung mga factors or what are the factors that will affect COVID variables like hospitalization days, no? The deaths. So mahirap hulaan. Kaya nga worldwide, di ba? So kung madali lang sana, siguro na-solve na natin ang COVID-19. So these are ongoing research, no? Searching for all factors that affects deaths, hospitalization dates, or recoveries, no? Or even the increase of active cases. Okay. So I have here X and Y. I will model Y in terms of X. So this is a linear function. I will use the function LM. Papangalanan ko yung model like model 1. Okay. Ito, pwedeng model 2 or any model. You can put your names, no, para madali yung tandaan. Okay, so arbitrary lang yun. Okay, and then you can do that. You can also superimpose the line. Actually, ito na yung line. Okay. But obviously, there's a linear relationship between the weight and the height. Okay. Tabi-tabi po, no? Hindi ko po sinadya na kunin yung weight at saka height. No? Pero obviously, your weight or the height are dependent on each other. No? Depende kung anong gusto mong hulaan. Is it the weight or is it the height? So dito, nagkataon lang na nandito si weight, the x-axis, and nandito yung height. Okay. Just to give you an example. Ang ibig sabihin niyan, the taller you are, then the heavier you are. Okay. Or the heavier you are, maybe you're taller than the rest of the people, okay, in this age. 0 siguro to hanggang 90. Okay. So yun yung ibig sabihin nun. So you can plot that. And then actually you can solve for the equation of this line. Meron na siyang slope, di ba? O yan, may slope na siya. And then yung intercept niya ay, ano pa to? Just below 130. Siguro 125. Yan. Okay. And ang age or ang weight niya is below 50. Tama ba? Yung mga below 5 feet dyan, malamang ang weight nyo ay below 50. Alright? Pero kung ikaw ay matangkad, no? Matangkad ka, malamang ang weight mo nandito rin, no? Ayan. So kung 90 kilograms ka, dapat matangkad ka, no? Parang may problema kung 90 ka na, sunod, nandito ka lang, 130, no? Wala ka sa statistics ko. Alright? Okay. So these are the normal, they're randomly put into the X and Y axis. Okay? Next. Alright. So after fitting your line into those points, no? Kailangan meron kang error analysis. So you do the residual analysis, i-fit mo, tinitignan dito, dapat konti lang. This is 0, meron kang plus and minus. Dapat konti lang yung differences mo from 0. Kasi standardized na to, no? So kung medyo lumalagpas ka sa range, no, ibig sabihin hindi maganda yung fit ng line. Right? Next, this one is the normal QQ plot. Ibig sabihin nun, after doing or after fitting, di ba, nag-solve tayo ng error. Ang error would be the difference of the predicted value and the actual value. So kung tama yung hula mo, kasi nanghula lang tayo, no? Yung hula natin, eksakto ba? Well, actually, it's difficult to give an exact value kasi wala kang error, di ba? Parang perfect yun. Okay. So, kung wala kang error, then you get a zero error. Or, I mean, halos lahat ng errors mo ay close to zero. Okay. Now, para masabi natin na maganda yung linear model, then you should have this, no? Ito yung line mo, then this point should fluctuate, no? Above and below this line. Kung ang points mo ay nandito lahat sa taas ng line na to, then there's something wrong with your model. Hindi maganda yung model mo. Kasi you should go up and down with this line. Alright? At ito naman yung standardized residuals. So, ganun pa rin. Dapat maliit lang yung residuals mo. Okay? So, hindi ka lalagpas. Depende doon sa measure, no, ng variable mo. Siyempre, kung malalaki yung variables mo, like 1 million, thousands, then malaki rin yung ano. But if you standardize them, then hindi siya nalalayo dito. Okay. Ito din, yung residuals pa rin to, is so madaming pwedeng gamitin for testing the model. And we can do this in R. So may mga packages tayo or functions that you can use in R. All right. Now, let's do some time series analysis. No? Ito lang examples, no? Kasi hindi ko mako-cover lahat ng statistical models. No? Actually, although yung title ko is statistical modeling, pero I'll just give you an example of what we are doing. Okay. So this is an example of a time series model of typhoid fever in Cordillera. O, di ba? May data ang Cordillera. So, this is from DOH. Salamat, DOH. Okay. So, ang ginamit niya is what? The whole Cordillera. Alright? And ARIMA model is actually auto-regressive, integrated moving averages. So, ano bang ginagawa dyan? So, yan. Meron kang time series. Siyempre, time series, no? Ang data dito are, I think these are monthly observations. Monthly ba? Yeah. Monthly observations from 2010 to 2017. Okay. Pero ang ginawa dito, ang ginamit mo is the data from 2010 to 2016. And then you fitted a function. Actually, ito yung ARIMA function, no? Nag-fit tayo dito. Kung titignan nyo, halos fit na siya, no? Well, we can also check if there's an overfitting of this model kasi pangit din naman kung may overfitting. Kung underfitting naman, medyo malaki yung distances, no, of the predicted value and the model. All right. So after examining this, no, and then ito na yung predicted value, right? Ito yung blue. I'm sorry. Yeah, ito yung dash line dito. So for it to be a very good prediction, dapat hindi ka lalagpas dito sa mga gray. Yan. So this is, I think, the lower 85% of your prediction. Ito yung lower 85%. Ito yung upper 85, lower 95 yung nasa taas. Upper 85, ito yung lower 95% or confidence interval of the predictions. Okay? So dapat hindi ka lalagpas. Okay. So, and then, tingnan mo rin, ano ba yung behavior, di ba? Ganito yung behavior. Pag ganyan, tapos biglang babalik, pag ganyan ulit, biglang tayo. Ibig sabihin, there's a seasonal pattern. So may seasonal pattern dyan. Kaya natin pinili yung SARIMA, parang seasonal auto-regressive integrated moving average. Okay? So this is an example for time series. Next. This one is the so hindi lang sa mga diseases, no? Ito naman yung ginawa ng mga students ko. Ito, sana yung isa dito graduate na. Okay, yung dalawa magdi-defend pa lang. Alright? So, they did a time series analysis of this South China Sea level using Sarima din. Okay. So, ang ginawa nila, ito. Okay? So, una kasi, you identify, may patterns ba? May seasonality? Well, obviously, meron, no? And so, you can check that by using some graphs. We call this the ACF, or the autocorrelation function. And this one is the partial autocorrelation function. So we use this to identify models like a set of ARIMA models. Okay, and then you can put some seasonality into the model because of the patterns that you observe. Okay, but before doing that, you should check kung stationary ba yung series mo. When I say stationary, is the mean constant, is the variance constant. Pag sinabing constant mean, well, obviously, walang increase dito, walang decrease. So, pwede nating sabihin na constant yung mean. Tapos, ang fluctuation mo, medyo, consistent, no? Except for this, merong mga matataas. Pero, may pattern naman, biglang bababa. Okay? So, yun yung mga variations. Okay? Or the variance. Okay? Or the fluctuation. So, dapat constant yung variance, constant yung mean. And then you can now choose among the Sarima models. Right? So, this is an example of, well, before you do the modeling, you should identify. Well, obviously, may pattern siya at saka hindi stationary yung original na series. Given that merong pag may lumalabas dito sa mga blue lines, ibig sabihin, may mga extreme values doon sa ating series. So, hindi constant ang mean, hindi constant ang variance. Alright. Okay. So, this is an example of a stationary model. Ibig sabihin, if I continue this, diretso lang, hindi siya masyadong lumalayo. Or, the series is not increasing. So, increasing kasi dapat gumanon yung series ko, no? Nagpa-fluctuate dito sa taas. Pero ito hindi. And then the fluctuation is normal. So, walang masyadong mataas. Okay? And then you can inspect itong, pag may lumalabas dito, ibig sabihin, you can now choose a model which will treat these extreme values. Okay. Ito, 0. Kung monthly yung data ko, then maybe this is 12, no? So, this will suggest seasonality into my model. So, imbes na ARIMA lang yung gagawin ko, lalagyan ko ng S because of this spike here and also here. Okay, so just giving you an overview. Okay. Siyempre, mahabang discussion ng time series. This is a whole 3-unit thing, no? Applied pa lang yon, and you can put on theories, mas mahaba, mga 5 units na siya. Alright. Okay. Sana matapos ko, no? 3:23 na. Alright. So, ngayon, after identification, I'm going to proceed with the estimation. Ibig sabihin, I will estimate my parameters kasi nasa modeling tayo, di ba? Mag-estimate tayo ng parameter. Okay. Sarima is actually a mathematical equation. No? So, meron tayong, you should put parameters to this. So, meron kang isa dito. This one, dahil seasonal siya, this one here, translate to a longer, I mean, more parameters, no? Maybe 12, ganyan, kasi 12 na yung ating, no? This one is not one parameter for the AR. This is autoregressive parameter for this value here, yung 1 dyan. Well, this could be 0, 1, 2. Pag 3, medyo hindi na maganda kasi masyado ng marami. No? Ito rin, this one is the differencing that we do in the making stationarity of the model, or making the series stationary, right? But this one is the moving average. Ibig sabihin, seasonal na yung moving average. Ibig sabihin, the pattern has seasonality. Alright? So, hindi ko masyadong madetalye, but well, sana maintindihan nyo ng konti using this graph. Pag ganito lang yon, if I use a Sarima model like this, I will inspect my autocorrelation function and partial autocorrelation function to give me an idea whether my errors are within bounds. When I say within bounds, maliliit lang siya. Ito, negative point 1 and positive point 1. Okay? Sa T yan, if the T value is 2.0 and below, then ibig sabihin, yung mga errors mo are are small, okay? And they are normally distributed with mean zero and sigma squared, or the variance, which is very, very small. Yun yung ibig sabihin ng normal errors. Okay. And after doing some modeling na like model 1, model 2, actually yung modeling dyan is iterative. Ibig sabihin, umiikot ka hanggang sa makakuha ka ng mas maganda pang model. So you can estimate and check the residuals ulit. Okay, mapapansin nyo, lumiit yung mga residuals. Residuals are the errors, right? Okay. And we can compare two or more models by using these measures of errors. Okay. This one is RMSE, the root mean squared error. MAPE is absolute percentage error that you will get the mean. Then you compare the number of parameters that you are estimating actually. Okay. So with these models, RIMA 1000011 and yan, you need to estimate 2 parameters dito. Dito naman 3 parameters. And now you decide kung saan dyan ang gusto mong model. Is it model 1 or model 2? I-compare mo, halos parehas sila. No? AIC, BIC, tapos ito, konti lang yung difference. Okay? Although mas maliit yung mean square error dito, no? May 3 kang variables na ini-estimate. Okay. So if you were to decide whether I will get model 1 or model 2, so depende. You can use both. But for the principle, using principle of parsimony, and I say principle of parsimony, dapat you go for the model having the least number of parameters. So in this case, maybe I can choose 2. Pero pwede pa rin naman ito, yung 3 parameters. Okay. So with that, nag-estimate, ito na yon. Ito yung forecast, which has same pattern. Pag ganun yung pattern, no? Aakyat siya and then biglang baba. Aakyat siya, biglang baba. So that's for 1 year, right? So maybe you can have, so anong months ba tumataas dito? Maybe siguro yung tag-ulan, kaya ito may tumaas dyan. Okay? Pababa na siya pag nagsa-summer na. Right? Mga ganun. Okay. Next, ito naman, I added this, right? The spatiotemporal analysis of measles, okay? I have done this with some or 2 PhD students, si Ma'am Jervy at saka si Ma'am Maricar. Okay, I just got this this morning. So it's now for review. Maybe after a month lalabas na to. A spatiotemporal analysis of measles in Baguio City. So we have data from 2010 to 2018, and we want to analyze ano namang nangyari sa measles in Baguio City. Is it persisting, or kung umaakyat ba, nag-i-increase ba? So from 2010 to 2018, meron pa ba? Do we still need vaccine kung ito yung nangyayari? Well, tingnan natin ano bang nangyari. Okay. So these are just bar graph, no? Comparing ages from 40. Ibig sabihin, yung mga 40 years old, nagkaka-measles pa, no? Kala nyo siguro pag tumanda na kayo, hindi na kayo nagkaka-measles. Well, hindi. Okay? Because according to this, no, meron ditong gray. Ano ba yung gray? Yan, no? 1 to 4 years old. Okay. Well, obviously, yung mga blue, those are the less than, mga neonates to, like less than 9 months. 9 to 11 yung susunod dyan. Okay. Pero tingnan nyo to, anong kulay ba to? So, meron pa rin. Yeah. Here's one. Yung mga nasa huli. Okay. Now, so how do you start analysis using this exploratory bar graphs? Okay, tingnan natin. In 2010, ganito yung itsura natin, no? Madami. Siguro may ginawa yung health authorities, biglang uh, from this value, no, bumaba siya. And then it continued to decrease. Pero maybe naging lax tayo, umakyat ulit siya. And then in 2014, so that's how many after 4 years, dumami pa ulit. Okay. So ibig sabihin, pag merong nangyayari in between these years o may nangyari in between 2010 to 2013, para ito ay umakyat. Okay? So siguro, nawalan ba ng vaccine for these ages? Yeah. And then after which, biglang bumaba. Okay. So ano kaya ang ginawa ng health authorities or the city? Okay. So ito, it maintained decrease ito, decrease. Tapos biglang umakyat. Okay? Bakit kaya? So kung umakyat dito, siguro, tingnan niyo yung pattern. Every 4 years, tumaas siya. Tingnan mo dito. Ibig ba sabihin medyo okay na? So hanggang 2018 ito. So to now is 2021. Ano kaya mangyari in 2022? Is there a pattern? Well, pwede nating tignan. But a model could predict that. Right? So if we don't do something about these patterns, no, wala kang gagawin like vaccination or pag-iingat, no? Well, boosting immune system siguro, then maybe this would recur after mga 4 or 5 years. Sana wag naman. Okay. So, this is another, ito yung spatial analysis na tinatawag. So, you're comparing 2010, 2014, and 2018 kasi from the bar graphs, nakita mo na may pattern. So, meron ba talagang pattern? So, ito yung ginagawa dyan. Pag sinabi mong 111, ibig sabihin, high siya in 2010, high. Low in 2010 yung 011, high lang siya in 2014 and 2018. Yung 00, ibig sabihin, wala siyang, in those years, 2010, 2014, and 2018, hindi high ang incidence. And ito yung mga places na sa Central District area, no? So, dito yung may hotspots ang tawag natin dyan. So, hotspots siya with on these years, 2010, 14, and 2018. Okay? Kaya siya tinawag na spatio-temporal because we include time and location then. Like these barangays. Kung nakikita mo dito, nagkahawaan itong barangays na to. Right? Ito din. So kung nasang barangay ka man, tignan mo yung kapitbahay mo. Mahahawaan ba ako? Like itong red na to. Ito nag-orange niya. After a year, would this become red also? Would this become hot spot also? So ganun yung analysis ng spatio-temporal. You analyze with respect to time and space or the location. Okay. So yun yung results natin. And persistent pa rin ang results. Okay, so you can also proceed with this one, yung epidemic modeling natin, yung SIR. So you can use, again, the R. Ang tawag natin dyan, yung TSIR, package of R. S there is susceptible. Ano ba yung B? Okay, B is birth. Okay? Kasi nakita natin yung mga neonates, actually, yun yung tinatamaan. So, kailangan merong isama natin sa model, yung birth. Ito yung mga susceptible. Okay? Susceptible meaning ito, lahat ng tao na individuals. You can compartmentalize yung susceptible individuals like you do neonates muna or the school children o kaya yung old. Pero malamang hindi mo nasasama yung mga old age dito kasi konti lang yung nagkaka-measles, no, under old age. Okay. And I here is the infection. Okay. So doon sa mga nakinig ng SIR model, you can include TSIR, no, in modeling diseases like infectious diseases, yung typhoid fever, measles, dengue, TB, and so on, and including the COVID data. All right. This is the spatiotemporal of typhoid cases. So, ito naman sila yung kasama ko sa paper. They are also PhD students in Yale. And sorry, si Sir Liwag ay hindi na po natin siya kasama ngayon. Pero we've included him as a co-author because he contributed also to this paper. Okay. And here is a comparison or a correlation between humidity and typhoid cases. So, hindi siya masyadong maganda, no? Kasi halos wala namang linear correlation. Actually, yung correlation mo maliit lang. It's 0.33. Right? Ibig sabihin nun, the number of cases of typhoid fever is well also correlated with humidity pero hindi siya ganon ka-strong. So maybe there are other factors that can contribute to this increase in the number of people who are infected with the typhoid fever. Okay? And so, ito naman, dahil spatiotemporal, no, ang ginamit niya dito is the Moran's scatter plot or the Moran's index. So, yung mga red dito, ibig sabihin, may correlation ang location and time of these barangays. So, kung ano yung lokasyon mo at depende sa time, siguro kapitbahay mo infected or yeah, a group of adjacent barangays may be infected pag significant ang correlation. Yun yung ibig sabihin nun. Okay? So, may mga pangalan yung mga barangays na yan, but we didn't put the names because if you publish in an international journals, the names of the barangays are not useful. Okay? So, yun lang yan. And also, ito naman, gumamit siya ng Poisson distribution, okay, to give us an idea kung ano yung probability na magkaroon ka ng cases of typhoid fever. Paano ba interpret to? Lambda is the mean, right? So, pwede nating interpret to as within a day, meron kang 68 meron kang 0.68% probability na magkaroon ng isa lang. Okay? So, yun yung ibig sabihin ng boson. Ibig sabihin, marami or there's a high probability that you don't have cases, no, of typhoid. Okay? Pag in 2 days, so meron ka ng probability, lumiliit. In 2 days, meron ka ng probability na magkaroon ng isa. So, yun yung ibig sabihin nun. So, kailan ka magkakaroon ng typhoid fever na isang case? Ito yung ibig sabihin niyan. Every after 7 or 8 days, we have one typhoid case. And this is true in Baguio City. Okay, Baguio City only. Ibig sabihin, in a month, you can have 4 cases of typhoid fever. So, yun yung ibig sabihin ng Poisson modeling or Poisson distribution. Okay? Sana naintindihan nyo. Now, let's proceed. This is dengue naman. So, ito naman yung mga co-authors ko, si Sir Balino, and then si Kenneth. Andyan sa DMCS si Kenneth ngayon. Okay. Sir Balino is taking his PhD. Si Kenneth is one of our research assistants, RA sa DMCS ngayon. Okay? So, this paper will come out soon. Kasi for proof na siya. Okay. I continue. Ano naman ginawa nila? Okay. So, ito naman. These are exploratory. Exploratory din yan kasi kino-compare nila yung male at saka female, no? Yan. Tapos, ito naman yung ganun pa rin, ages, so, comparing. So, nakikita nyo naman dito, halos wala namang increase except for this, no? Yung June, yung 2016, medyo tumaas siya. So, i-compare natin ngayon if there is a correlation or significant ba itong increase na to. Yun yung pwede natin gawin. Alright? So, we just looking on these graphs, we can also do check of correlations using spatiotemporal analysis. So, in 2014, so this is 2014, 2016, and 2018. So, yun yung pinag-compare natin. No? Mapapansin nyo na noong 2014, noong 2014, konti lang ang infection. Na bakit siya naging ang dami ng hotspot in 2016? Alright? And then, in 2018, nawala ulit. So if you do this, no, if you do this analysis, pwede mong makita and you can focus on these areas like dito sa gitna. So if this is typhoid fever, ano kaya? Saan nanggaling yung infection? Okay, sorry, this is dengue. So pinaghalo na. This is dengue. Anong meron dito sa lugar na to? Bakit ito naging hotspot? So if that's the case, mahahawaan ko ba ito mga kapitbahay ko? So, kasi dito may hawaan na eh. Okay? This is Camp 7. No? Ayan. This is in Central District area. Itong mga white dito, actually, may market dyan. Halos wala namang tao dyan. So, kaya yan naging puti. Okay? Pero dito, tingnan nyo, ito red na red. Sana, so if you have the data in 2020 or 2021, then you can compare ito, the 2018. So this is a progressing study, no? So pwede nating dagdagan ng 2020 siguro to see whether dengue efforts of the city is decreasing the number of dengue incidents in Baguio City. Okay. So pwede nyo na rin gawin yon sa inyong mga cities. Alright. Ito is just a comparison of the dengue. No? Pag nagta-time series analysis kayo, tinatanggal nyo, ito yung mga incidents, tinatanggal nyo yung seasonality, and so you can take the trends. Ito yung trend mo. So, for the yung mga early months like January, February hanggang April, mababa pa siya, and then bigla siyang tataas dito. Maybe this is September or October. And then, bababa ulit. Okay? Just after the rainy season. Kasi kung malakas ang ulan, malakas ang tubig, okay, di ba, inaanod yung mga dengue, yung mga mosquito. Pero, pag tumigil na ang tag-ulan, naiimbak yung mga tubig. So, dito tumataas ang cases. So, you can make a study on that. Comparing temperature, maybe rainfall, and so on. And you can also put yung mga tourism siguro, ganun mga factors. Okay? So ito yon. These are the months. No? Pag January, ayan, medyo mataas. February, March, April. Nandito tayo ngayon. Ibig sabihin, we expect dengue cases. So hindi lang COVID-19 ang meron tayo. No? So if this is April, May, June, July, tataas siya. Okay, July, August, September. And then pababa siya pagdating ng fourth quarter. So yun yung ibig sabihin ng plots na to. Okay. So, patapos na ako. Okay. Actually, yung statistical models is just summary, no, of kung ano yung pwede nating gawin. Then after this, I will what walk you through the R thing, right? So, hindi ko tatapusin yung slides ko. Okay. So, ano ba yung statistical modeling? So, in a couple of lectures, the basic notation of a statistical model is examples of ANOVA and linear regression are given. So, time series, nabigay ko na. And then, meron kayong R, o an idea on the R on how to do linear regression, time series, box plot, pie, bar charts, and so on. Okay, so ano ba yung ginagawa natin? So, the general problem would be, you're given a collection of, meron tayong collection of variables. Its variable being a vector, ibig sabihin, mahaba siyang data. So, kunwari X or Y, ganyan. Meron tayong data, no? And then, when you say specific trait, those are the variables. And then we do experiment. So, meron ka ng Y ngayon. The Y there would be your dependent variable. Ibig sabihin, ito yung gusto nating hulaan. Ha? So, sa statistics, manghuhula ka. No? So, if you do modeling, manghuhula ka. Ganun din naman sa mathematical modeling. No? Nanguhula rin kayo. Right? And statistic modeling is a part of mathematical modeling kasi mga equations din naman ang ginagamit. Right? So, gusto mong hulaan si Y. For example, the number of dengue incidents as a factor or as a function of several variables. No? Ito yung mga explanatory variables. No? Ito yon. So, gagamitin mo ito si XY, X2, XN para mahulaan mo si Y. Right? So, so, ano kaya? So, kung ano yung meron kang variables like siguro temperature, humidity, ano pa, rainfall, then gusto kong hulaan si dengue incidence. So, that's just an example, right? And so, yan na yung model mo. So, Y in terms of this X of I. And then you put some errors to your model. Okay. So, ang tawag natin dun sa Y would be the response variable. Ibig sabihin, yun yung result. And then, the explanatory variables would be your X values. And so, I want to model Y in terms of X. So, the simpler would be the linear regression. Okay? It could be continuous. So yung variable Y mo could be continuous. It could be categorical. And also the explanatory variables, it could be continuous, categorical, or a mixture. So ang tanong dyan, which variable is the responsive variable? Okay. So which variable would be your dependent variable? So ano si Y? At ano naman ang mga X? So, yun yung magiging problem. Or parang yung example ko kanina, the weight and the height. Asan ba doon ang dependent? Yung weight ba o yung height? So, yun, pwede mong pagbaliktarin. Depende kung ano yung hypothesis na gusto mong isa or i-prove. Okay. Are the explanatory variables continuous, categorical, or mix? Or mixture of both categorical and continuous? What is the nature of the response variable? Is it continuous? Okay. Is it a count? Ibig sabihin ko, nagka-count ka lang ba? Like the number of people infected? So yun yung count. So hindi ka pwedeng magkaroon ng negative values. Is it proportion? So percentage ba yan? Or mga ratios? Is it categorical? Is it categorical? Pwedeng yes or no, male or female, ganon. Or time at depth. Okay, so pwede rin ganun yung ating mga variables. Okay, so for those variables, meron tayong mga appropriate models. Like, if all the explanatory variables are continuous, then you can do regression. Now, why? Because you can compute for the mean, the standard deviation. You can put a line and the points between two whole numbers could be interpreted, no? So, pwede mang maglagay ng line. Yun yung ibig sabihin nun. So, you can do regression. So, you can do linear regression or multiple regression. explanatory variables are categorical. Then you use ANOVA. Ibig sabihin, you compare groups like the male and female. May pinag-iba ba ang variables mo between the males and females? Or between the young and the olds? Mga ganon. Or between private or public. So, yun yung mga categorical variables mo. And so, you do analysis of variance. Right? So, yung mga F-test na ginagawa nyo, chi-square test, pwede yung mga yon. Explanatory variables, both continuous and categorical. And then, so you use the analysis of covariance. Okay, so kung mix, so you can do ANOVA, right? And covariances or test of what? The variances, all right? Na pag continuous naman, no, yung response variable, ibig sabihin yung mga x variables nyo. So, kung lahat ay continuous, then you can do regression, ANOVA, or ANCOVA. Pag proportion lang, then logistic. Ito yung mga log linear regression, ayan. Or, yeah. And count, log linear regression, or you can also do the Poisson distribution na gaya nung ginawa natin kanina, or yung pinakita ko, yung probability of, ano ba yun, yung Poisson? Typhoid ba yun? Yeah. Okay. Yeah. So, kung ilang days ka mag-expect ng isang occurrence ng typhoid fever. So, that's another example of modeling account variable. Binary, when you say binary, pwede ito yung yes or no. Yan. So, pwede niyong gamitin to ngayong pandemic, papasa ka ba o hindi sa mga students? Pass or fail? Ganon. Pass o defer? Numerical or what? Equivalence lang. Key. And survival analysis. So, halos patapos na ako dito sa slide ko. Okay. So, yung mga model formulas na ginagamit natin, these are all so mathematical. So, pag nag-estimate tayo ng mga parameters, no, sa ating mga models, ang pinag-iba lang niya, bakit siya tinawag na statistical, no? Yung mga parameters natin or even the variables have statistical distributions like normal ba yan, Poisson ba yan, or skewed distribution ba siya, exponential ba siya, ganun. Okay? So, bago ako matapos, okay, para naman meron tayong time for the R, no? Paano ba lalabas dito? Sorry. Can I stop share ko muna, no? Stop share ko muna because hahanapin ko muna yung aking ano. Yan. Stop share. Alright. Cindy, andyan ka pa?
Yes, ma'am.
Okay. Wait lang ha. Maghanap ako ng site. Okay. Wait lang. Nasaan na ba yun? Okay. Ito ba yun? Okay. Try ko lang. Try. Yan. Okay. Now, for those who are teaching statistics, pwede sa high school, pwede sa college, kasi di ba sa tertiary, we have elementary statistics. Cindy, nakikita mo na to?
Yes po, ma'am.
Okay. So, mag-tutorial tayo sa R. Kasi, kunwari, no? By the way, pwede ko kayong matanong, anong software ang ginagamit nyo sa pagtuturo ng stat? Can we put that on the chat box para magkaroon lang ako ng idea? It could be SPSS, Excel, Google Sheet, what? Anong package ang ginagamit nyo? Can I see SPSS, Excel po? Wow. Okay, Minitab. May Minitab pa. Okay. SPSS, ang dami. Excel. Okay. May Stata. May SAS. Siguro statistician itong mga to. No? Alright. Ano yun? Okay, pinakamarami yung yung SPSS. Mayaman sila, may SPSS sila, no? Okay. Ang UP Baguio ba may SPSS? Wow, may Python. Walang R? May R. Yeah, R Studio. Pwede yan. Okay. Data. Python. Okay. All right. Salamat. Ayan. Thank you sa mga response, no? Hanapin natin yung mode. Ang mode natin SPSS saka Excel. May pa isa-isa, may R, may Python, okay, may Stata, may SAS, right? Okay. Ayan. Okay. So in UP Baguio only ilan ba? May 10. There are 10 license of SPSS in Baguio. So mga hindi nakakaalam na taga Baguio City, Samat, meron po tayong isa na license SPSS. Nasa akin po yung yung password or hindi ko alam kung pwede nating gamitin for the class. Pero ginamit ko lang siya dito sa aking laptop. So we have 3 in the College of Science and the rest are to the other colleges. Okay. So yun. Ang tanong, if you use this licensed software, okay, pwede ba natin itong gamitin sa mga articles natin? Well, yes, dahil may lisensya ka. No? May license. So you can put SPSS charts or figures into your paper. Now, paano kung wala kang license? Anong gagawin mo? So, kung wala kang license but you have the resources to use SPSS, then go. But you cannot put an output of SPSS into your article. 'Di ba? Kasi walang license yung ginamit mo. Right? So, yun yung problem. Now, kung gagamit ka naman SPSS to teach your students, the question is, are all students have license to that statistics software? Or yeah, okay, kung SPSS man yan, Stata or SAS, no? Bawal mong ipagamit ang hindi license na software sa mga estudyante. Well, lagi nating naririnig, ay, meron akong trial version. O, di ba? Gamit na gamit yan. Trial version. Good for 1 month. Na ganun. Then, after a month, wala, nag-expire na yung license mo. So, paano yun? So, what to do is, well, you have the output, i-transfer mo na lang sa iba. Encode mo ulit yung table mo or i-graph mo yung result doon sa ibang free na software. Okay. Now, I will run you through how you teach RE to your students. Okay. I have this tutorial, no? Online. Okay. Ano ko ba gagawin? Okay, eto yon. Okay. So, if you go here, nakikita nyo ba yung site? Hanapin nyo na lang yan, wawawa.r-tutor.com. Yan. And so you can follow me. Actually, ginagawa ko to sa mga estudyante ko in elementary statistics. Okay? Sabihin, if you teach, we call that Math 101, elementary statistics. Tapos meron din kaming mathematical statistics. And we use this, yung R. Kasi nga, isa lang yung, at saka bagong dating yung SPSS na software. So, you can go through the introduction of R. Nandito na yan, lahat. Okay? May mga examples. So, nandito yung mga basic data type. You could use numeric, integer, ganyan, complex. So, you can make computations on this, all numbers. May logic pa, logical. Okay? Complex, yes. You can do computations using vectors. Yan, ang dami, di ba? Arithmetic, Okay. You can do matrix construction, calculation, pwede ring list. Yan. So, pag binigay nyo itong, well, online na to sa mga students, baka mas mabilis pa silang matuto kaysa sa inyo, no? Kasi ginawa ko to sa mga estudyante ko, binigay ko lang yung website and then pagbigay ko ng dataset, no, I provide them the datasets and on the dengue, the measles, okay, the ano pa, yung mga infectious diseases na meron kami, and then they can do the graphs and the analysis, okay? So if you're teaching elementary statistics, kompleto na siya hanggang logistic regression, di ba? Yung tinuturo natin actually hanggang simple linear regression, di ba? Sa ating mga statistics. Nandito lahat. Okay? From the graphing, from estimation. So if I click this, meron siyang example. Alright? So this is an example or a data set what saved on that R. Okay, so you can get all the data sets in R and then you can practice doing the graphing and all the analysis using this tutorial. Wala po akong bayad dito ha. Sinishare ko lang sa inyo. Right? So, nandito na lahat actually. Okay? Kahit bayaan mo magbasa yung estudyante, ayan may mga output pa. If you do this, yun yung output. Right? So, ang gagawin nyo na lang is to interpret or you expand on the interpretation of the results. Like, ano ba yung, kung nandito ka na, ano bang ibig sabihin ng coefficient? Or you use your mathematics, right? Ano ba ibig sabihin ng intercept? Ganon. Right? Yan. Meron din ditong multiple regression. Yeah. Okay? So, hindi ka nag-stop doon. May multiple regression. Okay? And then, meron na rin dito yung logistic regression. Okay? In other words, hindi kayo mawawala because everything is in here. So, if you want to teach elementary statistics using R, then I suggest you go to this site. Libre naman to, hindi nag-expire. I've been using this for 3 years na yata ito. And this is very effective. Okay? Aside from the course notes that we give to our students, with this, alam na nila kung paano gumawa ng pie chart, ng bar graph, ng histogram, and they can do correlations of these variables. Okay? Some students are also using the QGIS, kung meron kayo noon, kung narinig nyo na yon. Free naman yon. So, pwede rin nilang gawin yon for the maps. Okay? Yan. So, kung may tanong kayo, you just go to this website. Yeah? r-tutor. Okay? I check the chat. Meron pa yata. Okay. Yan. Okay lang, gumamit kayo ng mga license na software for as long as your students can also make use of those softwares. Okay. What else? So aside from this, saan pa ba ako? Wait lang, hanapin ko ulit, no? Do I have time? Hanggang anong oras ba ako? May check. Hindi, hanggang anong oras tayo? 4:15. Tama?
Yes,
So,
ma'am.
habang naghahanap ako ng next na lecture, nang isi-share ko sa inyo, next na online, you can go to this website. By the way, I will provide my slides, no? Mukhang bibigyan kayo ng shared drive sa ating mga secretariat. May shared drive ba tayo for all the lectures? Yes, right. Hanggang 4:15 daw ako. Okay. Dahil hanggang 4:15 ako, I will give you more of this online tutorials na ginagamit ko. Okay. I have to stop share. Hahanapin ko lang ha. Diyan lang kayo. Saan kaya yun? Okay. Wait lang. Na-off na ano ko yata. Yung aking... Alright. Okay. Alright. Alright. Okay. So, share ko ulit. Online naman to. So, you can go to this site. You search for ggplot. Ayan, no? Okay. Our statistics, and then, or you can Google nyo na lang yung ggplot2, right? And then, meron siyang tutorial. Okay. And, ayan. So, may mga commands that you can do. Siyempre, may mga patalastas dyan. May mga advertisements, no? So, you can go here. Asan ba? Ito, intro muna. Ayan. So, you can go to this. ggplot2 tutorial, part 1. So, kung may part 1, malamang may part 2, right? Kompleto yan. Part 1, part 2, part 3. And ito, binibigay ko din to sa mga students ko, no? Tapos, pag nakita nila to, yan, they can provide all these plots there. Okay? Yan. Pwede silang, kasi ang mga bata, magaling yan mag-experiment, no? So, all the commands are here. So, hindi kayo mahihirapan. Right? So, kailangan nyo lang talagang intindihin yung basic of this R. But you can, dun sa una, syempre, mga pa kayo, ganun naman talaga. Kahit natutunan mo na, no? Kung hindi mo ginagamit, diba? Hindi mo rin talaga master. So, all you have to do is, ito, you can use them every now and then. You can use them in your classes kasi libre naman. Okay? And your students can also learn how to explore. Kasi yun naman yung pinakamaganda ngayon. Lalo na ngayong pandemya, di ba? Mas maganda pa rin na nag-e-explore sila. At hindi yung spoon feeding. Like, well, pag face-to-face kasi, parang ganun yung nangyayari, right? Ngayon siguro natuto ng mga students natin. O, di ba? So you can have these graphs. Pinapakita ko lang, no? Maybe, yun, di ba? Oh, so you can do that. And all the commands are here. So hindi kayo mawawala. Okay? Ayan. So you can use this website or tutorial. Okay. For my last few minutes, gusto ko lang share sa inyo. Nakikita ba, Ma'am Cindy?
Yes po, ma'am.
Very good. O, di ba? Siyempre, hindi ko makakalimutan ang ating COVID-19 analysis. Right? Give me time. Mga 5 minutes siguro. Okay. Now, we do this now. Meron kaming grupo sa DMCS. These are math from the DMCS. This is Sir Jonas. Ito, Sir Dison is a student sa MS Math. This is Miss Domilies, si Childen, okay? And this is Miss Criselda Libatique, yung ating ngayon, MC or moderator, facilitator. Joseph is our teaching assistant at DMCS. This is Raya Gueco, siya yung taga-post sa aming FB page ng Baguio. Nagpo-post siya ng mga analysis. Miss Orian is our research assistant employed by UP System. And this is Dr. Panes from the Baguio City Health Center, Health Services Office. And she's the one providing us all the data set that we include in this analysis. So, medyo, itong front page, well, nandito na lahat, no? Pero syempre, kinat namin. So this is a week data. Ito yung mga reported cases. Pag napapansin nyo, medyo less than 100 na siya. Nung April, lumalagpas to sa 100. Nakaabot pa kami sa 148 or 144. So, pwede nating sabihin na bumaba na siya ngayong week. Right? These are the active cases, 989. Ito yung pinakita ko sa inyo kanina. 989 ang active cases namin sa Baguio City. Okay? Dito medyo mataas pa. But, well, sad to say, ito yung mga deaths every day. 331. So, ito yung mga deaths natin in the week. Okay? And, ito yung mga recoveries. Ito pala yung total deaths, 223. Ang naka-record dito ay 223. Alright? Recoveries, ito yung recoveries. Medyo mas mababa ang recoveries kaysa sa new cases. Ibig sabihin, tumataas pa rin itong active cases natin. And these are the total infected. Okay? Ito yung mga tests. So, ang infected natin, nasa 11,000 na. 11,000 plus. Baguio City lang to. And these are the tests done per day. Alright? And ito na yung negative. Ibig sabihin, we are testing at marami ang nagne-negatibo sa mga test. So if you add all the negatives and the positive, ibig sabihin, nakagawa na tayo ng mga 17,000 tests. Okay? Pero yung mga test na yan, hindi siya unique. Ibig sabihin, yung isang tao dyan, maybe nakadatlong test na, nakadalawa, okay? Especially the health workers. Pero umabot na tayo sa 17,000 tests. Pag i-multiply mo yan sa presyo ng isang RT-PCR, then ang laki na, di ba? Siguro, i-times 4 mo na lang yan. So, yun yung expenses ngayon ng city. Alright? So, yan yung pwede nating aralin. Bakit ba ganyan? Ganon. Okay? So, I have 4 more minutes. Can I run you through the deaths cases? So, ito yung deaths. Ang recorded namin ay 226, no? Kasi may mga naka-record na tinanggal dahil hindi pala siya taga Baguio. So ito yung sinasabi ko sa inyo kanina, no? That most of the deaths are above this one, 60 to 69. Okay? That's about more than one-fourth. More than one-fourth of the death cases are age 60 to 69. Alright? So, yung 226 natin is about 2% of the infected. Ibig sabihin, for every 100 infected people or individual, 2 of them dies. So, yun yung reality, no? And most of them are above 60. At ito yung babantayan nyo. If yung relative nyo, kamag-anak nyo, kakilala nyo ay nasa age 90 to 99, then ito yung may highest case fatality ratio. Ibig sabihin, there's a high probability that the patient will die. Kaya iniiwasan natin na ang mga seniors ay ma-infect. Alright? So this would be a bigger problem. Yung kung bakit dumami ang namatay noong May 16, oh. Ano ba to? First week pa lang, pero 16 na ang namamatay. Ganun ba? April, may 82 ka. Now, bakit biglang dumami? In contrast to the deaths in March, 20 lang naman yun. 11 lang nung February. So, pwede niyong hanapan ng solusyon to. Bakit ba? Anong mga variables bang meron tayo noong April? Is it the temperature? Is it the additional variants na meron tayo? Yun yung pwede niyong pag-aralan. Okay. I have 1 minute to browse through. Okay. Alright. I go back to that. Okay. So, dahil 1 minute na lang, o di hanggang tingin na lang tayo. Alright? So, ito yung analysis na ginagawa namin, okay, in Baguio City, and we update this daily. So daily natin tong ginagawa. So pag receive namin ng data, encode, or we clean the data and then we do the graphs. Okay? So ito yung pag namasyal naman kayo sa Baguio City, take note, ito po yung mga active cases natin. So wag po kayong pumunta sa sentro. Pwede kayo dito sa gilid-gilid. Yan, sa mga bundok-bundok. Huwag kayo pumunta sa sentro. Like the malls, the market, mga ganyan. Because those are the locations of active cases. Although ang active cases naman nasa hospitals, di ba? Wala, hindi naman sila nagkakalat. Okay? Pero most of them or some of them pala ay nasa home isolation facilities or home, nasa mga bahay-bahay. Okay? So with that, I guess I have to end. Hindi, yung mga gustong mag-contribute dito, you can contact po the authors. This is my email address. We can give you a copy, siguro PDF copy of this. But the data, well, hindi pa tayo open data, no? So medyo pinag-iingatan natin yung data. So siguro we can give the PDF copy of this study. Medyo mahaba po to. This is 130 pages na paper. Okay, I think that's all. Thank you so much. I hope you enjoyed the 3 days na lecture. So, Ma'am Cindy, tapos na po ako. Thank you very much.
Thank you, Ma'am Belle. Please stay. Participants, please stay because we still have the closing remarks from our dean. Okay, let me just introduce her. Okay. Our dean, Professor Dimfna Javier, earned BS and MS Geology degrees from the University of the Philippines in Diliman and PhD Geographic Information Science degree from the University of New England in Australia. Prior to joining and rejoining UP Baguio, she was employed as a geostatistician in a private gold mining company. She has been with UP Baguio for over 30 years, teaching courses in geology, natural science, and science, technology, and society. Her research topic interests include geographic information science, natural hazards, climate change, and disaster risk reduction. She has actively engaged in research and published on the topics of rainfall threshold for landslide and landslide susceptibility estimation methods using GIS undertaken in selected areas in the Cordillera. Several of her research output earned international publication awards by the university. Professor Javier is a licensed geologist and regular member of the National Research Council of the Philippines. She is currently an associate professor of geology at the Department of Physical Sciences and serves as the Dean of the College of Science at the University of the Philippines, Baguio. Without further ado, may I give the floor to Professor Dimfna Javier. Thank you.
Good afternoon. Thank you for the nice introduction, Miss Cindy. I hope everyone is okay and so enriched by all the lectures that have happened in these past few days. May I have screen sharing rights? Can I share?
Yes po, ma'am, you have already.
Yes, sir. Okay, thank you. Second. So, okay, so this will be brief. Chair of the Department of Mathematics and Computer Science and concurrent chair of the 26th SINSM, Dr. Rizavel Addawe, to the dynamic and energetic members of the DMCS faculty and team of teaching assistants, research assistants, and volunteers, and especially to our 1,162 dedicated educators from over 600 schools here and abroad. Good afternoon. First, I would like to extend my heartfelt congratulations to all you lifelong learning participants who successfully completed tracks in calculus, general mathematics and statistics, differential equations, and basic programming in the mathematics and computer science cluster of the SINSM. We are sincerely honored and privileged that despite the challenges of the pandemic, you have joined us these last 3 days. We are hopeful that each of you have learned, unlearned, and relearned basic concepts and appropriate instructional techniques that will further enrich your roles as educators. Each of you have a unique role to instill among students the skills not only of computing, but more so in solving complex problems and thinking critically and creatively in mathematics and beyond. Initiated in mathematics courses, such life skills can also be applied to a broad range of disciplines essential in finding local and global solutions for food security, poverty alleviation, environment conservation, natural hazards mitigation, climate change, and a host of others. We wish you all the best in your endeavors at imparting math and science lessons in your classrooms, not only for the purpose of improving the PISA or TEAMS ranking of the country, but also for the goal of molding scientific-minded citizens of a developing nation and the resilient, sustainable global community. I laud our participants' continuing efforts in upgrading their capabilities in math and science teaching. May I invite you all to consider pursuing graduate studies offered by the College of Science, the MS Mathematics and BH Mathematics programs, and also the MS Conservation and Restoration Ecology program offered by the Department of Biology. In September this year, the college, together with the College of Social Sciences and the College of Arts and Communication, would be involved in the inaugural offering of the PhD Indigenous Studies program, which will later offer a novel course called Ethnomathematics. May I also invite you and your colleagues in the forthcoming activities of the SINSM. The biology cluster will be held on the 13th to 15th of May, carrying the theme Genetics and Cell Biology of the Crossroads of Different Biological Disciplines. The physical sciences cluster will be held on the 19th to 21st of May with the theme Interested, which is acronym for Innovative Teaching and Research Methods in Science and Technology Education. And then we will have the Human Kinetics cluster on the 25th to 27th of May with the theme Adapting to the New Normal. This is how we do it. We hope to see you and your colleagues in future SINSM engagements later this month and next year. Last but not definitely the least, I may extend the kudos to the DMCS faculty, teaching assistants, research assistants, and volunteers for a successful SINSM. Have a science-friendly and safe weekend to all. Maraming salamat at magandang hapon po.
Thank you, Dean. Thank you so much po. Yay, we are done. What's next, Mom Cindy?
May,
Dean,
may,
thank you.
oh, nga. May I request picture taking?
Okay.
Hello, Dean. Thank you po. Tapos na.
You're welcome. Tapos, tapos.
Okay, tapos na kami. Picture taking na.
Congrats.
Oo, thank you,
Thank you.
ma'am.
Congrats.
Thank you.
Highest record participants.
Request naman pong pa-stop share.
Yes. Sorry.
Thank you.
Okay. Thank you.
All right. May I request everyone to please switch your cameras on. This will be our last picture taking, and thank you for participating in our SINSM 2021. Okay. Count to 3. Hang on. Ayan. Okay. 1. Marami to ha. 9 to. 9 na slides to. Kaya bear with me. Okay. 1, 2, 9. Okay. Next. Ulitin natin. Sige. 1, 2, smile. Okay. Second. All right. Okay. 1, 2, smile. Ayan. Okay. 1. 9 to. 9 na slides to. Please. All right. Thank you. All right. Next. Okay. 1, 2. All right. Hang on. Okay. Wait. Marami-rami eh. Third pa lang tayo. Okay. Para lahat kayo makapture. 1, 2. Okay. Ay, isa pa. Nahuli. Camera ni sir. Wait lang. Okay. One more. Okay. Fifth. Smile. Okay. Next. 1, 2. Smile. Okay. All right. Next. 1, 2. Okay. Dalawa na lang. Yan.
Okay lang, Cindy. Go.
Sige. 1, 2. Yung iba wala ng camera, oh.
Oo nga eh.
Bale. Last. 1, 2. Alright. That's it. Hindi ko na...
Baka may mga hindi nakuha. Pwedeng magstay tapos sila mag-picture. Okay. Sorry, hindi na tayo nakapag-Q&A. Thank you, Dean.
Sorry.
Yay, tapos na kami.
Congrats.
Thank you po.
DMCS.
Thank
See you
po.
ulit 2022. Every year po ito. Sana face-to-face na, no?
Okay.
Thank you.
Sinong gustong magstay? Picture
Yung
pa?
gustong magstay, magpipicture. Yung mga hindi nakapag-photo, yung mga hindi naka-online kanina, you can stay and then we'll have photos. For those who have not put their cameras on kanina, you can stay for a while para masama kayo sa photo.
Okay. Hopefully mabasa namin lahat yung mga iba pang mga messages.
Basahin mo, Cindy.
Ma'am?
Basahin mo.
Oo nga eh. Sandali ko pa ito i-save. Francis, masisave mo ba to? Paano ba siya i-save?
Oh, mamaya kapag nag-end na yung meeting, masisave ko siya.
Okay, sige. Thank you. Okay. Sige, game ulit. Waki? Hi, Dorem. How are you?
Hi, Ma'am Cindy. Congratulations po, Mabel.
Hi,
And sa buong
Jorem.
department
Hi,
po.
Sir Jorem. Yay! Nag-attend sila. Thank you.
Hi po, ma'am.
Hello.
Yes,
Uy. Andito ka.
Camera.
Kumusta na?
Ayos naman, ma'am.
Wow. Thank you. Nag-attend kayo. Nagtuturo ka na ba?
Yes, ma'am.
Very good. Saan school?
St. Rose po. Catholic school po.
Wow. Congratulations.
Thank you.
O, sige. Game.
Galing-galing mo siguro magturo, no?
Bro. Ma'am, ina-apply ko lahat ng mga natutunan ko dyan sa inyo.
Very good. Magturo ka ng stat, ha?
Yes, ma'am. Yes, ma'am.
Congratulations, UPP.
One.
Okay.
Ano nangyayari sa
Okay po, online. Nag-picture ka na? Okay
Ayan.
po, online para maka-reach kami sa Mindanao. Wow, may mga taga Mindanao. Thank you again, especially to the lecturers.
Shot lang ako ng shot, ha? Bahala na kayo. Mag-emote dyan. Yan. Go.
Thanks, College of Science daw. Thanks to the faculty and staff. Salamat po.
Welcome po. Kasi hindi ko man mai-present ko naman yung certificate of appreciation mo.
Wala na ako certificate. Bad ka naman.
Nakalimutan kong i-display. Alright. Maki,
Happy Mother's Day daw.
Mother's Day sa lahat ng mga nanay. Okay. Sa mga feeling nanay. Saka sa mga tumatayong.
Thank you sa DMCS. Yay!
Yay, tapos na tayo!
Pa kayo?
Happy!
Ang lakas na ng ulan, hindi ko na kayo marinig.
Ako din nga, mami. Kaya nga sumisigaw ako.
Oo.
Okay, last na nga, Rod. One. Sandali. Wag muna mag-message. Sandali nga. Ayan. Wag muna mag-message. Okay, para clear yung ano natin. 1, 2. Alright. 1, 2. Hindi ako makaganon. Sandali. Paano ba yung... Dalawang daliri talaga eh. Thank you everyone for joining. Ang saya-saya. Ang dami-dami.
Nakakamiss daw ang UP Baguio, mga students natin. Oh. Happy Mother's Day!
Oh, ayan. Basta picture lang ako ng picture. Mag-on lang kayo ng camera nyo. Makikita nyo to sa Facebook. Ganyan.
Ilan po pala dito, ma'am, mga estudyante niyo iba?
Yes. Diba? Dami.
Opo.
Parang mas maganda yata virtual lahat tayo, no? Mas madami nakaka-attend ng SINSM natin.
Ma'am, di po kailangan dumayo from ano eh.
Correct.
Okay.
Diba? Kahit nakaupo ka sa bahay mo, then attend. Thank you. Then, ang daming thank you. Oh, lahat sila nag-thank you. Mga certificates nila, ibigay nyo ha. Evaluation forms daw, padala nyo. Thank you. Nagbabasa ako, dami naman. Hindi ko na natapos. Meron daw, equation daw ng ARIMA. Yes, you can put the mathematical equation on the ARIMA model.
I sent it already, ma'am.
Thank you.
Yes.
Ay, nako.
Pwedeng pa off na yung YouTube natin. Sir Francis,
Sige po, off ko na po yung YouTube.
thank you.